1, 2, 3. Okay, great.
Welcome to the launch of the world's first ocean cleanup system. Today is a historic day, not only for all of us here at the Ocean Cleanup, but the entire world. From this day forward, we hope to start pulling more plastic out of the ocean each year than we dump into it. Hello and welcome. My name is Kari Lundgren, and I am speaking to you from the control tower at the former Naval Air Station at Alameda. It is a beautiful day here in the Bay Area, and we've got a great show lined up for you. What I can tell you at this point is that the Ocean Cleanup's system number 1 is making its way towards the Bay Bridge. We've actually been enjoying a great view of it as it's passed behind us from Anchorage 9. From the Bay Bridge, it will be going to the Golden Gate. That will take about 2 hours, give or take. I say give or take because nothing quite like this has ever been done before. And while we have done our very best to plan everything down to the last minute, you just never know. But don't worry, we have you covered every step of the way. Quick run through of how today is going to work. As I said, the system is going to be passing under the Bay Bridge fairly shortly. And there's going to be a little bit of fun there because we actually have a I'm a little bit of surprise. I'm not going to tell you about that. But there is going to be something fun happening under the Bay Bridge. It's at that point is going to go past Treasure Island. And then around 1 o'clock, it will be passing to the south of Alcatraz. As you can see, according to this map, it was originally planned to go north of Alcatraz, but it is going to be going to the south. So between 1 and 2 p.m., it will be going right in front.
So in order to solve a problem, you really first have to understand
of
the problem.
the
early days,
right in front of the San Francisco waterfront. So a great view. So if you are in San Francisco and you want to see history in the making, make sure to head down to Crissy Field, to the Golden Gate. Anywhere along there should be good viewing. We've got lots of suggestions on our website. We've got cameras all around the Bay Area. They are streamed to you live using some of the latest technology from LiveU. And we have got a great team here at the control room in Alameda. And we'll be sharing lots of cool information about the system, how it was designed, how it was put into the water. We'll be, of course, discussing the problem of plastic pollution, and we'll be introducing you to various members of the team. And speaking of which, I think it's time that I mention my colleague Rachel Richardson. She is on Treasure Island at the Metre restaurant. Rachel, can you hear me?
Hey, Kari, I am actually here at the Metre on Treasure Island, like you just said. It's a beautiful day outside. The sun is shining. It's not too windy. It's like Mother Nature is sending us a gift. And I'm actually here with a lot of people who helped build System 1. They're all right here behind me. Say hi, everyone. Yay. Everyone's so excited. I think Wilson System 1 will be passing us really soon, and we're all super stoked to see it.
Can you see anything at this point?
No, not just yet, but I hear that we're going to be seeing it any minute now.
And is that a good place to be standing? If you're in Oakland and want to see the system, should they head to Treasure Island?
It's a good place. There are actually a lot of great places where people can view it. If you go to our website, we've listed a lot of great viewing spots, or wherever you want to view the system. If you're watching at home, watching here in San Francisco, take a picture, let us know about it. We're on Facebook, Twitter, Instagram. Just use hashtag #TheOceanCleanup. Show us what you're seeing. Tell us your thoughts. Ask us questions. We want to hear from you guys. We have an amazing social media team who's actually here today as well. They're going to do their best to engage with you guys and answer all your questions throughout the day.
Thanks, Rachel. Things are looking very nice on that end. I'm a little bit envious. We'll be touching base with you in the not too distant future. So thanks a lot. Quick run through again of how today is going to work. at noon. The system will be passing under the Bay Bridge. There will be a surprise there. I'm going to ruin it and just tell you that it's a water salute, so stay tuned for that. We're going to be going past Treasure Island, then to the south of Alcatraz, and between 1 and 2 p.m. we will be right in front of the San Francisco waterfront. So if you want to see history in the making, head down to the waterfront as soon as possible. At 1:45, I should also mention that we will be speaking to Boyan Slat, who is the founder of Ocean Cleanup. Now, how did we get here? Well, 7 years ago, a 16-year-old Dutch boy went on a family holiday to Greece, and he came away with the following burning question: how do we rid the world's oceans of plastic? Well, it's probably a question many people have asked over the years, young and old. Perhaps you're one of them. Maybe you've gone fishing and picked up a plastic bottle, or been kayaking and seen a plastic bag float by. Perhaps you've even participated in a beach cleanup or discussed the issue at work or school. Well, this young boy went a step further than that. He turned the question into his high school science project. He then made it the focus of his university studies. And when he felt even that wasn't enough, I have to pause now. This is the water salute. God, what an absolutely fantastic image. Thank you to the Port of San Francisco. Thank you to the San Francisco Fire Brigade. Gosh, this is an absolutely great image.
Oh.
And a real send-off. I have a feeling they're maybe seeing this from Treasure Island at this point. Now, you are just seeing the front of the system going under the Bay Bridge. The system is 600 meters long, 2,000 feet. The nose of the launcher to the end of the system stretches over 1 kilometer if you include the launcher, the tow rope, and the system. So this is going to take a little while to pass under the Bay Bridge. I am sure that everybody on that launcher, we have 12 members of the ocean cleanup team. They are aboard that launcher, and I am sure they're very excited to be getting up close and personal with this water salute. As I said, this is a history in the making, and we're actually going to go ahead and jump into learning a little bit about the early years of the ocean cleanup. And so we have a documentary for you all about that.
So in order to solve a problem, you really first have to understand the problem. In the early days of the technology development, say 2014, 2015, it became rapidly apparent that we simply didn't know enough about the problem yet to be able to develop an optimal solution. Then we wondered, well, why is that so? Why don't we know enough? Researchers have been doing great work since the 1970s, actually, in terms of mapping plastic in this Great Pacific Garbage Patch. But the thing was that the data was very scattered, and we had this hunch that there was this measurement bias towards the smaller pieces because of the way we have been sampling in the past. To solve that, we thought, well, let's cover a larger area. What if we just cross this Great Pacific Garbage Patch with 50 boats at the same time, all taking measurements in parallel, and that way we do cover a very large area and get a good sample of what is out there. By that point in time, the exact number of vessels that we had secured for this expedition was 0. Definitely it required a lot of cold calling, just us driving from marina to marina in Hawaii and California, spreading flyers around. So the question to you is, are you willing to join this expedition? It was quite a lot of work, but eventually I think it paid off. We chartered a former NOAA vessel as a mothership for the fleet, and eventually we got to 30 vessels.
There is a lot of plastic in the oceans. It's scary, guys. Over.
think we got this time even more. I got a lot of plastic, bigger plastic pieces.
By September 2015, we completed the mega expedition. We got all our samples in. It was a survey effort of unprecedented size. But while doing so, we collected a few ghost nets, which are these very large sort of balls of nets and ropes, which are very dangerous to marine life, to vessels as well. The number of nets we collected was too low to do good science with, to do good statistics with, but it was high enough for us to have a suspicion that this would be actually a very major component of the problem. But we just crossed the ocean with 30 boats at the same time, and then we thought, well, to get a good analysis of these nets, we need to cover an even larger area. So how on earth are we going to do that? How would you normally cross a large area? Well, you would jump on an airplane. So then we thought, well, what if we actually got ourselves an airplane to do this survey? And that actually led to the first aerial reconnaissance mission of an ocean garbage patch ever. We crossed the Great Pacific Garbage Patch with a C-130 Hercules aircraft twice. We fitted this airplane with the most advanced aerial sensors in the world, which included shortwave infrared sensors as well as LiDAR sensors. And this is really the same technology that self-driving cars use, where we actually are able to get a sort of a 3D point cloud of the debris, through which we are also able to estimate whether it was just debris or a net at the surface, or whether it actually went down. So then we had the count, we had the volume, and through that we could actually estimate, based on the nets that we got with the mega expedition, how heavy those nets would be. And now it actually turns out that the nets that we spotted would actually comprise about half of the mass of plastic out there in the Great Pacific Garbage Patch. So then we had these shipping containers full with ocean plastic arriving here in the Netherlands. We have these 1.2 million pieces of plastic, and somehow we need to count them, and we need to turn this physical matter into data, into numbers. Within no time we found ourselves a group of interns. They started this monumental effort of actually separating the plastic from the plankton with a pair of tweezers, one by one, day in, day out, and I just have this immense amount of respect for the work that they did. And then it was really time to put the paper together. And really the challenge was to take this huge amount of data and then present it in a concise manner, compact enough so that we can actually submit it to a journal. Now our research found that there is about 80 million kilos of plastic floating around, which constitutes to 1.8 trillion pieces of ocean plastic inside the Great Pacific Garbage Patch. Interestingly, I think these results will again change the face of what the Great Pacific Garbage Patch actually looks like. Back in the 90s, when this big story about the garbage patch started appearing, through the media, it was blown up to this island of plastic where you could actually walk on. As the years passed and more research came in, that kind of flipped completely the other way, to it just being these small confetti-sized pieces of plastic which you could hardly see with the naked eye. And now what we see is that actually the truth is somewhere in between. Well, sure, it's not an island you can walk on, but it's definitely not just confetti-sized pieces of plastic either. Even though by count, most of these pieces of plastic are small, if you look at it from a mass perspective, actually most of the debris is large, and we see that about 92% of the plastic isn't microplastic but is large plastic. These results also show why it's so important that we are cleaning up this garbage patch in the near future. Because when you think about it, those 8% of plastic that are already microplastics, they used to be large objects as well, but because of UV light, it breaks down into these smaller and smaller pieces, becoming harder to clean up and magnifying the impact of the problem. So these results now allow us to further improve our cleanup technology, and it also gives us a baseline to which we can compare the success of the cleanup. So we know the point where we start, and then while we're cleaning up in the next few years, we can continue to measure how much plastic is out there and then compare it to the baseline and see how far we've come.
I mentioned earlier that we have got cameras all over the bay, but we also have a camera in the Netherlands because that is where the ocean cleanup was born. And we're going to actually show you a live image from the new offices of the ocean cleanup in Rotterdam. Hello, everyone.
Yeah.
There's a big team there, and I'm sure all of them are quite excited. They're staying up late. It's about 9 hours. It isn't about, it is exactly 9 hours ahead, but I'm sure that none of them mind staying up late. We can still see, actually no, yeah, the water salute is still going on behind me under the Bay Bridge. As I said, the system and the Maersk launcher, the tow line, are over 1 kilometer long, so it's going to take a little while for the system to get under the Bay Bridge. This vessel is also, the Maersk launcher is towing at a fairly slow pace between 2 and 4 knots. Now, you've seen some shots of the system, and you will be seeing close-up shots that we will be getting to fairly shortly. One thing I'm going to mention, because you may be wondering, is on the side of the system there is system number system 001, but you may also notice that there is the name Wilson, and that is a nod to the movie, the Tom Hanks movie Castaway, in which he befriends a volleyball and nicknames it Wilson. But hopefully our Wilson will be doing a great deal more work than that volleyball was doing in the movie. We are actually going to jump to a little bit of history about Boyan and his story. As I mentioned, he had this idea at 16. He is now 24, and there was a lot that happened in between. Or maybe we're not jumping to that. Maybe we can get some more images of the system as it goes under the Bay Bridge, or maybe I can give you a little bit more information about it. So the system at this point is 2,000 feet long, and it is in a straight line. When it gets out to the Great Pacific Garbage Patch, it is actually going to form a U shape so it can start collecting plastic. It is a passive system. There are no motors. There is nothing that is going to drive the system along other than ocean currents and waves. The idea is that as long as it goes faster than the plastic, it will gather plastic. Once it has a fair amount, we'll be seeing that using a camera that is in the middle of the system, and that will be beamed back to Rotterdam. Once it is seen that there is enough plastic, then a ship will go out and gather it, and it will come to shore to be recycled. We are actually going to jump to a video with a full, detailed explanation of how the system is intended to work, and that is what we're going to show you next.
1.8 trillion pieces of plastic float at the surface of the Great Pacific Garbage Patch. Here, the ocean cleanup is deploying the world's first technological solution to this growing problem. The principle behind it is simple: create a coastline where there are none. Concentrate the plastic, and take it out. The system consists of a 600-meter-long floater and a 3-meter deep skirt attached below. The floater provides buoyancy to the system and prevents plastic from flowing over it, while the skirt prevents smaller particles from escaping underneath. As the impenetrable skirt creates a downward flow, marine life can safely pass beneath it. Here is how the system catches plastic. The system takes advantage of 3 natural oceanic forces: winds, waves, and currents. Both the plastic and system are being carried by the current. However, wind and waves propel the system only, as the floater partly sticks above the surface, while plastic is primarily just beneath it. The system thus moves faster than the plastic, allowing the plastic to be captured. The skirt extends deeper in the middle of the system than on the outer edges. As the current applies pressure on the skirt, the system naturally adopts a U shape, which enables it to concentrate plastic in its center, like a funnel. The drag generated by the skirt also acts as a stabilizing force, allowing the system to reorient itself when the wind changes direction. And because the system, like the plastic, is free-floating, it automatically drifts to the areas with the highest plastic concentration. Fitted with solar-powered lights, anti-collision systems, cameras, sensors, and satellite antennas, the system actively communicates its position at all times and continuously gathers performance data. Periodically, a support vessel comes by to take out the concentrated plastic, like a garbage truck of the ocean. The plastic is then transported to land, recycled, and made into durable products. This is the first of a fleet of 60 systems. Once deployed, the fleet is expected to clean up 50% of the Great Pacific Garbage Patch every 5 years.
50% of the Great Pacific Garbage Patch in 5 years is a pretty incredible number when you think about 1.8 trillion pieces of plastic. That is 250 pieces of plastic for every human being on Earth. So a vast amount of work that this system is going to start doing. We're seeing some fantastic images of the system and the Maersk launcher. Looks like it's riding quite nicely through the water, and it's coming up to the water salute. I think we're going to try to touch base with Rachel and see what things are looking like from her perspective. Rachel, what are you seeing?
Hey, Kari, we are now actually seeing the system as it's passing us. It's pretty incredible. We just watched the water salute. It was absolutely bonkers. Everyone here is super excited. One of these people is actually Henk van Dalen, who's the project manager here at the Ocean Cleanup. So, Henk, what are you thinking about all of this?
Well, I'm an extremely happy man, Rachel. You know, what's going on over here really is years of preparation by the whole team. We've gone through engineering phases, the Rotterdam office really giving their best efforts there. Moving with the suppliers through to procurement, the assembly team with local contractors, building the whole thing. And now here, it's all coming together. This is absolutely great.
It is so great. And I was actually with you on the Maersk launcher a couple of days ago, and you were actually feeling a bit bad that you weren't actually able to stay on the boat.
Yes, I won't tell my wife, but I would love to join these guys, you know. The atmosphere on the boat is so good. The guys have been working hard together with the Maersk crew to make sure everything's prepared, set for the big trip. And yeah, I think they're having a blast offshore there, and I kind of wish I was there as well.
Well, your secret's safe with all of us. We actually just watched a video about the technology, but since we're seeing it in real life, in person, maybe you can give everyone a little brief overview about the system, the technology.
Okay, well, what you're seeing here is our System 1. It's a 2,000 feet long ocean cleanup device. It consists of a 48-inch diameter floater sitting on the sea surface, and we have the 10-feet screen connected below it. Now on top you'll see white instrumentation and white lanterns. This is actually to make sure we adhere to the marine navigational safety requirements and make sure we're highly visible offshore when we operate.
Okay, and you mentioned the screen, and I know that was actually something you'd encountered a few challenges with that. Maybe you can explain a bit about that.
You can say a few challenges indeed. Now the screen is, you'd almost call it the screen adventure, you could say. Now we have a screen which is quite of the complex part of the system. It has some contradicting features. You know, you want to keep it stiff in the vertical plane to make sure the plastic doesn't escape, but you also want it to be highly flexible to move with the pipe over the ocean. Now these are quite contradicting, and what you often get is that the materials tend to fail. And that's what we've seen a few times during the prototyping phase. Now after the prototype 2 of the North Sea, we decided to develop a screen team and really dive into the details, relook, lessons learned, and start from scratch again to make sure we get a good screen concept. And what you see here today is the result of that. It's a screen made of a geotextile material. There's ballast weights connected below it, so it's strong enough to hold these vertical loads, yet the material is also flexible to do what I mentioned, follow the motions of the oceans there.
Okay, very cool. And throughout all of these different iterations, what was one of the bigger challenges in making this new screen?
Well, I think what we found was that there was no one-stop shop. You know, you have good materials, but then it was difficult to make them connect them together or connect areas with the ballast weights. So it was really looking at concept designing, making sure that the materials match the type of concept you're looking for, matches the behavior of the the system. And that was really what the whole concept phase was about, and it was definitely challenging for the engineers, but I'm very proud of what they came up with.
Yeah, and I mean, one thing that's important to note is that everything we're doing has never been done before. I mean, from all the different aspects of it, we've had to create a lot of things from scratch. So I think it's absolutely incredible what everyone has done here. Thank you for talking with us today. Thank you. And yeah, I'll pass it back to you, Kari.
Thank you, Rachel, and thank you, Hank. I think you can, Hank, you can start enjoying yourself. I think Rachel at this point is going to be jumping on a boat, but we will see. We'll be seeing images of that, and we'll be touching base with her later in the show. Now, of course, the man of the hour. Time to hear from him, and we're going to learn a little bit more about what today is all about.
On September 8th, 2018, the Ocean Cleanup will launch its first ocean cleanup system into the Great Pacific Garbage Patch. Over the past 5 years, since the Ocean Cleanup was founded, we've done a lot of work to get to this point. On one side, understanding the problem, many reconnaissance missions, expeditions, and on the other hand, doing all the scale model testing and prototyping and calculations to make sure that we can eliminate every risk possible before launching this system. We believe that every risk that we can eliminate in advance, we have been able to eliminate. But that doesn't mean that all risks have been eliminated. Truly, the only way to prove that we can rid the oceans of plastic is to actually go out there and deploy a world's first ocean cleanup system. And there are 3 main risks that we hope to be able to tick off in the coming months. The first one being the behavior of the cleanup system. So does it indeed get propelled by the waves and the winds? Is it able to rotate around fast enough when the direction of the wind and the waves change? And does it make this nice U-shape that we want so that the system is able to act like a Pac-Man? This is something we've been able to study a lot with scale models, with computer simulations, but I'll still be very relieved when we are able to see this in reality. And this is something that we hope to see already during the trials before we reach the garbage patch. So hopefully by September we'll be able to confirm this very fundamental part of the cleanup concept. So the second risk we'll be tackling with our first cleanup system is the interaction between the plastic and the cleanup system. So are we able to efficiently collect the plastic, and are we efficiently able to retain the plastic? And to me, this is where I think my largest anxiety lies at this point in time. First of all, it's something that we haven't really been able to test very well. We've done scale model tests on it, but these are things that you have to take with a grain of salt. It's very hard to scale the plastic. You have things like surface tension, which will influence your results. So even though the models now predict that we should be able to capture plastic down to around the millimeter range, this is something that we can only truly find out when we deploy a full-scale system in the Great Pacific Garbage Patch. And the third and final risk that we'll be tackling in the coming months is the survivability of the cleanup system. Now, the ocean is a very destructive environment. You have waves, very high waves, you have wind, you have strong currents, you have the UV light, you have animals nibbling on things, and of course you have the salt. It's a very corrosive environment. So just having something in the ocean, man-made, that's able to survive for long periods of time, that's already quite an achievement. Now, I have a lot of faith in the engineers that have spent tens of years in the offshore oil and gas industry designing these massive structures that have survived for a very long period of time. And I also think that we're being helped by having a system that is very simple, so there's not a lot of things that can break. But still, I'll be very happy if the system goes through the first winter without any significant damage. So definitely, I think in April, we'll be happily ticking off this final box.
So there you have it, the 3 things keeping Boy and Slat up at night. Well, as I mentioned earlier in the show, we've got some very excited people wanting waiting up late at night to talk to us and to enjoy this launch. As I mentioned, this idea is born in Delft, Holland, and the Ocean Cleanup recently moved to Rotterdam, Holland, and that is where the headquarters are now. We've got Josie, I'm going to mispronounce this, Josie Miners, not Jose. I'm a bit in the Bay Area, a little bit too long. Josie, you are a longtime Ocean Cleanup member, and you are head of HR and recruitment. Tell us what the atmosphere is like there.
Oh, it's great here. We're so excited. Everybody is pumped up with energy and high voltage here. Yeah.
So a fun fact about Josie, she actually lives on a boat in the middle of Rotterdam, and that is one of the reasons that she was drawn to the Ocean Cleanup. Tell us a little bit about that story, Josie.
Yes. Well, a couple of years ago, I decided I wanted to live on a boat. It was always my dream. And I saw all kinds of trash around my ship, balloons and plastic and stuff. And then the vacancy came along for the Ocean Cleanup, and I thought, well, living on a boat, cleaning up the ocean, well, what else?
Well, and as I mentioned before, you are the head of HR and recruitment. You've seen the Ocean Cleanup go from 30 people to now over 80 people. And if I remember correctly, you actually send a document to prospective employees called How We Roll. Tell me a little bit about that.
Well, that's a little bit of our culture, to check if you like our culture, because not everybody likes the same cultures. And yeah, our culture is all about innovation and high performance and freedom and responsibility. You think everybody likes that, but not everybody is used to it, and not everybody can perform as high as our brilliant crew can do that. So you need to fit.
Well, and it looks like you're not struggling to get recruits back there. It looks like you've got a very eager team, and of course the team here has been very excited as well.
Yes,
thank you, Josie. We will be. If you have any questions or any comments, make sure to send them our way. And actually, speaking of which, make sure to be staying in touch on social media. Hashtag the Ocean Cleanup and at the Ocean Cleanup. Definitely send us your questions, send us pictures. We would love to see if any of those sailboats that are out on the bay, if you could be sending us shots back, we will be trying to share them. And now, what is next? Boyan. Well, 2018 has been quite a busy year for the Ocean Cleanup, and that's maybe because things have run a little bit ahead of plan.
So, what's next? Our promise was to start the cleanup of the Great Pacific Garbage Patch by the end of 2020. But unfortunately, we cannot keep this promise. So instead, we are here to announce that we will be launching our first actual cleanup system to be deployed in the Great Pacific Garbage Patch, the one that will start the Ocean Cleanup within the next 12 months.
Am I done? No.
Soon after that event, the Ocean Cleanup started scouting out locations around the world where they would build the world's first passive ocean cleanup system, and that went quickly from planning to execution. In February of 2018, it was announced that Alameda would be the official location of the build of system number 1, which is where I am right now, and it has been an absolutely fantastic location, a location with a lot of history, I might add. For all you aviation nerds, this was where Pan Am, the China Clipper, originally flew from. The San Francisco Bay Area, of course, offered plenty of space, but direct access to the Pacific Ocean. One of the first members of the team to scout out this location was Bart Buisman, and we actually have some of his thoughts in a documentary of what it was like when he first came to the yard.
I am Bart, I'm the project engineer, and we are at the yard, Alameda yard, and this area is just really amazing. This is this old deserted airport. You got a lot of startup companies here, a lot of energy going on. Yeah, it's, I think this place really suits the Ocean Cleanup, and this is where it's all going to happen. So now there's just some concrete slab here, but soon trucks will drive in through that fence and bring all the pipes. So basically we're going to set up an old assembly line here. There will be pipe sections lined up with a welding machine. And over there in the corner, come with us, I'll show you. So we're going to set up an assembly line right here, where we're going to weld the pipe joints together. It's about at ground level. And then the pipe will be elevated to a height of 1.5 meters. And then there will be the screen assembly area where we put the screen underneath the pipe. And then right after the screen is attached, it will be launched into this lagoon there. And then we do our last checks. And then the towboats will come and tow it out through that opening there. Around that area, underneath the Golden Gate Bridge towards the Pacific Ocean. So that's basically what's going to happen here. Very exciting stuff. This is where I've been waiting for since I've signed up with the ocean cleanup. So yeah, I'm very excited about this.
In March, the first pipes arrived, and they were coming from Agru in Austria, and the ocean cleanup hit the ground running. One of the first people here was our operation manager, Ric Martini. He's actually out on the Maersk right now, heading out into the Great Pacific Garbage Patch. We might actually be getting some visuals of the whole team on the Maersk a little bit later. But here is Ric telling us about how 51 pieces of plastic become an ocean cleanup system. Maersk Lusha. What did I say?
Well, we're getting the first container with the first part of the first ocean plastic cleaning machine. So it's the moment everybody has been waiting for. So I'm gonna move the first container on our lot there and make sure we get this thing moving. Well, I'm happy the first one has arrived, finally, after a hold-up of 1.5 hours on the highway. But we're getting there. The moment when I get my staff and I get my people, we're entering a complete different kind of portal.
I'm Julius Lijn, I'm the technical superintendent here at the yard, and I'm going to make sure that all production is according to our specs. There are all kinds of different pipes. We have pipes with bulkheads, we have pipes with bollards on top of it. We have pipes with a tow head, so that's like the end termination where you would pull through the water. It's really finding the right pipe for the right position, and that's actually a bit of a challenge here.
So the most important equipment that we have here is the welding machine. And that's the machine that's welding until we have 600 meters of floating unit. So that's a lot of welding. Well, the HTP welding is completely different from steel, as it doesn't need any additional material. So what we do is we heat the two pieces of the pipe, and then we press the two pipes with a slow pressure increase together and leave it there for hours to cure. And it's one of the slowest welding processes in the world, but it's also the highest quality. So it's not a problem taking all the forces that the pipe is designed for, because it's stronger. HTP has the amazing ability to become even more flexible once it starts flexing. So once it starts to react to the waves, it will slowly but surely follow the waves in the swell quite easy. The better the system follows the waves, the more efficient we can capture plastic.
You have this dovetail here on the bottom. You have to align them nicely, because if it's offset, then you cannot install the screen that will be below the pipe. So yeah, it is not just baking pipe together.
Look here. We're good. This is still okay. This is still okay. And here we are.
I'm happy with the progress that we made, as the 120 meter unit is almost nearing its completion. The atmosphere on the project is completely different than other projects. It's just a vibe going on here. It is something special and I'm enjoying it every second.
Something special indeed. Well, I think we're going to be checking in again with this system and giving you some live shots of from the drone. Let's see, can we see system number 1 out in the bay at this point? As I said, it's gone from underneath the Bay Bridge. Ah, there we have it. Those are some beautiful shots. So we were just listening to Ric Martini. He's actually aboard the Maersk. He's one of 12 ocean cleanup staff who are on the Maersk launcher, I should say, Maersk launcher. A few points about this tow. This ship is not used to pulling light ocean cleanup systems. It has a single winch on board that can pull 500 tons. The system weighs 380 tons. So you can imagine that the captain is dealing with slightly different challenge than he is normally used to. This ship normally pulls things like oil platforms. Little side note, a little bit of fun. The captain is from the Faroe Islands, so we've got a real mix of nationalities and expertise on this ship. There are 30 people. And it's also interesting to note that it's, as I mentioned, a mix of expertise. We've got biologists, engineers. These people are going to be looking at how the system behaves in the Great Pacific Garbage Patch, and yeah, keeping an eye on the marine biology. And we even have a fisherman. He's going to be fishing for plastic instead of fishing for fish. So that's kind of exciting for him. Now, a project of this size obviously required some unique testing to get where we are today. The biggest test was last May and June, when a 120-meter long test section of the pipe was sent out to see how it dealt with the actual conditions of the Pacific Ocean. Our own Reinder de Feiter was actually went along on this test. He's actually also aboard the Maersk launcher, and he gave us a report of his experience of the tow test as well as the inspection afterwards.
I'm Reinder de Feiter. I accompanied the tow test during the last 2 weeks as a technical superintendent on board of the Scorpius vessel. Yeah, I'm pretty excited. This is the first step of the ocean cleanup towards a viable solution for ocean plastic. Cheers! We started off here at the yard. We got on a crew boat, head to the Scorpius, the big ocean tug, which took us out. And as soon as we got on the tug, we stepped into like a big unknown, basically. Of course, we've been testing at the North Sea on the shorter section of 12 meters, but 120 meters, out of which 72 equipped with screen, that's never been tested. I mean, with every wave, we thought, oh, how is the system going to react? Will it survive? Will all the stuff stay on? I'm amazed by the stability of the system with like these big waves. The second day we hit 5 meters and it was incredibly stable. Upon the first inspection of the floater and of the screen, it proved to be basically untouched. The screen was perfect condition, and then every day after it's been one big testing event. Coming weeks, our focus will be on first examining the screen. We'll look at every single stitch, every little connection, to make sure that we don't miss the little details, because those details are what matter. Those details make or break the screen eventually in system number 1.
My name is Chris Reichert. I'm the lead structural engineer at the Ocean Cleanup. I've been involved mainly with the screen design over the last couple of months. Screen is very important as it's required for the plastic capturing efficiency.
The date is June 6, 2018. The dive is to inspect the screen on the Ocean Cleanup pipeline. Minor signs of wear. Roger.
So in the next couple of days we will be extracting the tow test segment from the water and bringing it back to shore, where we continue on with the inspections of the screen.
My name is Arjen Chalama. I'm Technology Manager on the Ocean Cleanup project. We saw some little damages on the screen, but we expected those and we already mitigated them in the updated screen design that we will use for the full system. We are looking really closely in all those stitches, and up to now we didn't see any loose stitches during the inspection, so that's really a good sign, and it really gives us confidence in the way of manufacturing the screens, that they are okay for deploying them for a long period of time in the ocean.
Design, make, test, break, repeat in action. That is a bit of a mantra here at the Ocean Cleanup. Now, you are seeing a design that is going to be going through a great deal of additional testing. The idea of how it is going to collect plastic, that is something that has not been tested yet in the real ocean conditions, though pieces of the pipe, as we just saw, have been tested, and of course there have been previous prototypes, and that's actually what I wanted to mention right now. There are 3 prototypes before system number 1, and they started with this idea that you could use technology from the oil sector, say oil booms, like what you would use for collecting an oil spill. So that was sort of the original idea, but that did not stand up to the test of time, which is why you are seeing on system 1 this high-density polyethylene pipe, which is a type of plastic. It has a lot of very special properties, which is why we are using it here at the Ocean Cleanup, and it came all the way from Austria. Underneath it, of course, is this screen, which we were just talking about. It's very soft material. I was feeling it here at the yard here, and I sort of expected it to be a bit like a sail, but it's actually much softer, and that was a very important thing to design right, because obviously we do not want to endanger any sea life. Just a reminder, social media, if you have got pictures, if you have got questions, please use the hashtag #TheOceanCleanup, and we're also at the Ocean Cleanup. And of course, check out our website. There's lots of information there. And actually, we're going through a lot of information about how the system came into being, and a lot of that is on our website. So if you missed any section, if you have questions, just check that out. Now, I haven't mentioned this yet, but one of the things that changed recently in the design was some stabilizers that were added to ensure that the pipe didn't roll. That happened about 6 months ago. You can see the stabilizers on the system. They are the big blue things. Sorry, I should find a better descriptive term for that, but they are the big blue metal pieces with the pods on top, the white pods. And those are helping ensure that the system doesn't roll. Now, the person in charge of design and that process was our mechanical engineer, Fede Popnik. And here's a quick story from the mouth of the man who designed the stabilizers.
As in any project, we started out with this really simple concept of a pipe with a screen underneath it. But then we started adding all kinds of necessary things like the navigation equipment, the satellite uplinks, the lanterns. And then all of a sudden we were like, this thing is going to capsize, it's going to roll over. So all of a sudden we needed something to keep the pipes up straight in the water. So we came up with these stabilizer frames. But we flagged this problem kind of late, so it was kind of a rush job to make these stabilizers. Or let me rephrase, we had a limited time window to come up with the design and to put them on the pipe. It's quite a big thing. Installation is not completely straightforward. You have to put in quite some attention. It's so cool and so strange to see it in real life, and yet it's so familiar because you spend so much time working with it already. And I know every part, I know every bolt. It's quite amazing to see a concept, an idea, to see it come to life like this.
Support on this system. That is to relay back data about how the system is behaving. It's to make sure that ships know where the system is. There's even electronics throughout the pipe, so things that will tell you how the pipe is handling the strain of being at ocean. That is quite complicated electronics, and we actually caught up with one of our electrical engineers, Joel Jansen, when the pods arrived in Alameda to tell us a little bit more about those pods and what they're capable of and the types of information that they would be sending back to Rotterdam. Here's
Welcome, my name is Joel Jansen. I'm the lead for the electronics of the ocean cleanup. What you see here is 5 pods and 5 masts, which are going to be assembled here at Power Engineering. You see here 4 solar panels, and that supplies the power to the pods. So inside this cylinder there's batteries, battery management system, a computer and a number of other electronic equipment. And these masts have additional sensors. So what you see here is the AIS, and that warns vessels which are passing at 20 nautical mile that the barrier is located there. We have a weather station monitoring wind speed, wind direction, and we have these beacons. These are Wi-Fi beacons, and it means that all these pods can communicate with each other. And it can communicate for over 1 nautical mile with the support vessel that's going to be on site for the first part of the project. Another small thing that's really important, we need to know where the barrier is, and we will know that with this small hockey puck. It's a GPS sensor, and that will give the position information via satellite. So here's the satellite that will send all the critical information from the system, and you can think of whether the flooding detectors, whether that gives a high signal, the position, location, pictures, movies. We can all get all that from the middle of the ocean all the way to Rotterdam at any time.
It's pretty incredible to think that a camera, which is located at the center of this system, is going to be, in a few weeks' time, sending photos back from the middle of the Great Pacific Garbage Patch. And I never thought I would hope to see camera shots of plastic, but that is exactly what I'm hoping, because this camera is part of the design to help the team in Rotterdam know when there is enough plastic and when a ship needs to come out and start collecting the plastic. Just a reminder of how this system works. It is one big, long, 2,000-foot, 600-meter long pipe at this point. When it gets out to sea, it will actually be pushed into a U shape. It is completely passive. It is driven by the wind and waves, and that, as long as it is going faster than the plastic, then it should collect plastic. All that plastic will be gathered by a garbage truck of the sea and then taken back to shore. Now, just a short month ago, this system was getting put into the water, and that took a lot of hard work, a lot of hard work, because it may look simple, but there are over 10,000 bolts that needed to be put precisely into place. So we're going to go into a feature on exactly what needed to happen to make that work.
big thing today is that we're going to prepare the pipe for launch. We're going to pull it 72 meters out, and then the pipe will be wet. So that's a big milestone today, because we're going to move into the wet phase. Yeah, so once this pipe is in the water, there's no way back. The train has left the station and we got to keep on going. So that's a big day today.
All you need is like 3 feet of water. Not even 3 feet, 2 feet, so we should be okay.
So we're about to pull this whole section, launch it in the water, so we can weld the next quad joint. What's a bit tricky today is that we got these tarps here. We have to make sure they pass the rollers and they don't get caught behind it. So this is the kind of operation where you need a lot of eyes, you need a lot of people to watch. It's a move that needs to be well coordinated.
My name is Tijmen Smit and I work for the Ocean Cleanup as yard manager. This is what it is all about, move pipe. Today was a good day and we needed it. We had quite a lot of issues to overcome and a lot of decisions being made. And today we made it happen and pushed the first lengths of pipe in the water. This project is unique by its size, by the techniques being used, by the time frame we want to put it in. We do that with a great team. And what I learned and experienced is that, especially in a situation where everything is new, never done before, you need all the crew on deck. Some guys bring really expert knowledge to the table, and you need to utilize the best out of every team member to make this happen and make this a success. And my job is basically a simple one. It's just bring that up in everyone, combine it where bring the knowledge to where the need is and bring the need to the knowledge and guard that the fun factor stays in. So this really helped me for my role a lot, because today we had a success. Like the first segment is in the water, it all went well, we didn't hurt anyone, we had no issues with our equipment. Everything went according to plan. And we learned a lot at the same time for the next one, and that will be much smoother. And by producing every day, people will feel really comfortable and feel really proud. They will reload energy to overcome whatever issue will pop up later. But this one is in the pocket, really is.
I am now joined by Tijmen Smit, who was the man in charge of making sure all of those 10,000 bolts went into place. Tijmen, you were the yard manager here in Alameda, and how does it feel to, I mean, you can't even see your system anymore. It's almost in the middle of the Pacific garbage patch at this point.
It's gone, but for me it is a big relief. It all went well. First of all, it's a big relief. Second of all, I look very much forward on receiving the first data out of the ocean after the first couple of weeks.
And as we just saw, you were the yard manager here, and you know, people should know that you have a long history at sea. You were in the merchant marine. How does this compare to some of the challenges that you've seen previously in your career?
It doesn't compare to anything I've done before. It doesn't compare to anyone on the yard has done before. So for our contractors, nobody has done this before, but there's a lot of experience along the contractor. There was a lot of experience laying with me, and with that combination, we got the crew lined up and trained. We got some processes in place, and then we were working on systems, improving them a little bit. So that enabled us to really go fast in a learning curve and deliver the system on time. Yeah. On the right quality, and with no injuries.
Well,
very important as well.
No, it's very important that nobody gets injured, and it's quite a. I mean, it's such a simple system, but in some ways it requires expertise from all sorts of different sectors of the marine, you know, from the oil industry, from engineering, from fisheries. Tell me about that.
Yeah, the challenge was not the complexity of the system, well, about building it, not the design, but building it. So the complexity was like this very rigid timeline we were on, this unexperienced crew, this contractor who was very able to build big concrete and big buildings and quays and harbors, but have never built any system like this. So the challenge lay in getting the knowledge to the issues and getting the issues to the knowledge, and then solve and proceed forward.
And Power Engineering, they were one of the partners that helped along the way. Tell me a little bit about their involvement.
Well, I think this was a perfect fit. Power and the ocean cleanup was like the best fit you can imagine. And it lies in that Power is this marine contractor who's very capable of building large structures. So they have all the knowledge in engineering, and ocean cleanup like at a start. They don't have ever built anything before. So that mix was a good fit, but not at the start. We really need to work on how do we do this and learn quickly, improve our learnings.
And that's where these toolbox, you had what you call toolbox meetings. Yeah.
Oh yeah, I think that was like the summit of it all. So this very steep learning curve ended in that we were like an oil production machine, where really Power was running the show, and there were set targets on the day, like this is what needs to be finished. They even had the MPV of the day, and we shared our successes. This was like a model.
And actually, I think we have some footage from that particular toolbox chat. So let's jump to that.
Yeah.
I think the MVP of the last 3 weeks is Larry himself. Yeah!
Ladies and gentlemen.
You know, this whole thing is something that not only I believe in, but I know you guys all believe in too. And this is really one of the most important projects I think I've ever been on. It really is. And I know you guys feel the same way. I can see it in your eyes. I can see it in your actions. And this has been amazing to watch this whole group. Every one of you has been innovative in your thoughts and in your actions, and you know, it's just been it's been a pleasure. So let's get our asses to work.
Yeah. Pretty excited right now, man. Getting to the last screen, seeing it all come together. It's amazing.
It's awesome. Everything is coming together. We're building the first system, and yeah, we're gonna get rid of this problem. And I'm super proud of being part of this project. It's inspiring.
All right, let's try.
Good, it's wet all the way.
Wilson got his feet wet.
It means a lot to me to be part of such a, really a historic part of history here. Something that a lot of people have said it impossible, but yet, looking back on this in 20 or 30 years, when I have kids, it's going to be awesome to tell them that, hey, I was a part of this great mission.
Yeah, the whole system is here in the lagoon behind me, and we just put the last stabilizer in the water.
I have very good hopes for the future. We put together this whole system in a very short amount of time, and we have a lot of lessons learned, so we can implement those lessons to improve the next systems.
We just installed the last stabilizer on my last day on the job, so that's awesome news.
It's something coming out of space. It's gonna land on our barrier.
seeing this arriving, that means that we're one step closer and gives confidence that we're able to make the goal of ridding the ocean of plastic. And that's what I signed up for, to make this possible, and I'm confident for the future.
Yeah, I have to say I feel really proud when I look behind me and to imagine where we were 6 months ago and where we're now. Yeah, I'm really proud.
To now see system number 1 fully assembled here in Alameda, yeah, I mean, it's quite surreal. I mean, you've seen the drawings for years, literally, artist impressions, and to now see it in reality is just pretty amazing.
We've talked about the problem of plastic pollution. We've talked about the design of the system, but now it's time to talk about the man of the hour, Boyan Slat himself. Well, I didn't mention it earlier, but Boyan is actually on a boat today. He is on the Harbor Emperor, which is being loaned to us by the Blue and Gold Line. Thank you very much to them for letting Boyan be on there. He's on there. It's our media boat today, so he's on there with a whole bunch of journalists. So he's fending off both journalists and a little bit of seasickness, because he does get seasick. Now, you might be wondering what sort of person sets out to change the world at 16. Well, I can tell you that Boyan was born in Delft, Holland, which is a lovely little city southeast of The Hague. He went to Grotius College. I hope I'm pronouncing that correctly. His favorite inventor is Nikola Tesla, and his current bedtime reading is Global Catastrophic Risks. But you're probably interested in a little bit more than a few fun facts, so we've put together a feature on Boyan, and here it is. If you have any other questions... Oh.
So I've always been very passionate about technology and making things, I think, literally all my life. I've been building things since I was 2 years old, things like tree houses and zip lines and computers, and followed by explosives and rockets. And then when I was 13, I decided it would be fun to launch 213 small rockets at the same time and get a Guinness Book of Records notation. So I've always had my projects, but it was just for my own enjoyment, I think. But then when I was 16, went scuba diving in Greece, saw more plastic bags than fish, and I just wondered, why can't we clean this up? Pretty soon I realized that the whole consensus in the community of people that worked on this problem said, well, that would be completely impossible. The ocean is way too big, the plastic moves around, it would kill sea life, it would just be a bad idea. So the best thing we could do is not make it worse. But I thought that was just a very uninspiring thing to say. Well, I also care a lot about the truth, so it has been really part of my instinct to question authority and to always try to distinguish between what's truly a fundamental truth, so something that is anchored in either physics or evolutionary biology or something truly fundamental, or what is simply a story or a consensus of opinions. And then when I listened to these arguments that people said, well, you can't clean it up, I didn't hear any of those physics-based arguments. The only thing that I heard was opinions and consensus. And I thought, well, let's just give it a try and see whether there is a way in which we could do that. And that's how I then founded the Ocean Cleanup.
Now, there is an old saying that it takes a village to raise a child, and that is certainly the case in the case of the ocean cleanup. Boyan system number 1 may be Boyan's baby, but it took a whole village around the globe to make today happen. I spoke to Boyan earlier this week, and he remains incredibly grateful for all of the help from those of you who took part in the original round of crowdfunding in 2013, which raised $90,000, and to the 38,000 1,000 of you from 160 countries who helped him raise over $2.2 million in 2014. And of course, there have been contributions in other ways of time, of expertise. There have been many volunteers. There are many volunteers today as well. Actually, Rachel Richardson, who I was speaking to earlier, started at the ocean cleanup as a volunteer. And if I'm not much mistaken, Rachel is now in the middle of the bay, right up and close with System 1, with Wilson. We would, let's try to jump to Rachel and see if she can hear me.
I am now talking to you live now from the bay. We have caught up with System 1. We just left Treasure Island. We hopped on a speedboat. We made our way over here, and it's absolutely incredible. We are followed by, there's the Maersk launcher, pretty impressive. The entire system, I'm almost without words. I mean, the entirety of it, I think, stretches, as Kari has said, it's almost 1 kilometer in length. So you see it, it's absolutely immense. And we're also surrounded by a media boat. That's where Boyan is right now. We have a sailboat that's following. It looks like all of the ocean is here to celebrate, and it's a pretty amazing sight. There are even birds sitting on top of it, so you know, it seems like everyone's enjoying it today.
How does it look like it is traveling through the water? Is it moving smoothly? I don't think Rachel can hear my question, but it looks like it is traveling, so I'll answer it myself. It looks like it is traveling very smoothly through the water, probably helped by all those tow tests that we mentioned earlier. As I said, 2 120-meter sections of this pipe have already been out in the Pacific, but the rest of it is completely new to these conditions. So that will be something that the people on board the Maersk will be monitoring. There are 12 members of the ocean cleanup team on board the Maersk, and they're going to be going out into the middle of the Pacific garbage patch. The plan is for it to take about 3 weeks. They will go out a certain distance from shore and be doing a bit of testing about how the system works, and then they will go from there to continue on from there to the Great Pacific Garbage Patch. That process will take about 3 weeks. Then the system will be set up and it will start collecting plastic. We actually hope that plastic will be coming back in the coming months. So that is something that we will be very excited to see. I know Boyan will be absolutely thrilled. He's mentioned several times over the last couple of days that that's really what he is looking forward to. Now, I think we are going to mention, well, we have been talking about it all along, that this is something that has never been done before. And we've got a couple of people, a couple of members of the team talking about precisely what a challenge that creates.
So what we're doing is pretty unprecedented, taking a structure as we are building it into an environment as we are taking it. We're using materials that have actually been applied in offshore conditions or other similar circumstances, but never in exactly that condition. So we are looking with new glasses to existing technology and existing materials and applying it in a different way. So that's really very exciting.
When the first system will be out in operation, there's actually two things that we gain from that. And the first one is that we want to show that this works for ourselves, but also to the outside. This is a new thing, so we have done a lot of testing, model tests, different things, but we haven't seen the real system yet. So once it's out there, we want to, well, see if it really works as intended. And the other side of it is that we want to learn as much as we can, because this is so new. We want to gain a lot of knowledge from it and then use that knowledge to learn from how it behaves out there, what it's actually doing, how the ocean behaves, how the plastics behave in front of the system, and use that knowledge to design a second system that will be better than the first one.
Now, by tackling one environmental problem, we here at the Ocean Cleanup didn't want to create another one. Now that Wilson is underway, we have a number of environmental experts aboard the Maersk launcher, and they will be keeping an eye on how the system behaves over the coming weeks and months. One of those people is Francesco Ferrari, who is the person we're going to hear from next.
If the mindset beyond the ocean cleanup wasn't that we care about the environment, the ocean cleanup itself would not exist. That's just the main assumption of the existing of the company. But besides that, we do consider that technology is effective to solve a problem only in the moment in which it does not generate another one. And in this case, if we want to clean the ocean from the plastic, we should be sure that while doing so, we don't spoil the same environment that we try to protect. I am Francesco Ferrari. I'm the Environmental Monitoring Coordinator. My function on the ocean cleanup is to consider the environment during the process and be sure that any impact that the ocean cleanup system might have on the environment, we can monitor it and we can mitigate. From my point of view, this last year it was really meant to be prepared for deploying. There is something really interesting in the unknown of doing something that has never been done before. On the other hand, how do you prepare for that? So basically this year my main focus was to understand the complexity of all the impact that the barrier can have on the environment, and for that we did an environmental impact assessment, and we are working on an environmental management plan which is focused on addressing the possible environmental concern. But on the other hand, it was a personal preparation and the team preparation for when we go out there. So for example, we had organizations like NOAA which supported us on the training to become a better observer, to become better in rescuing animal. In case, while we are out there and there is an emergency that is related to marine animal, we could intervene, or at least we have the tools to do so.
And I think we're going to be looking at a view back towards the Golden Gate Bridge at this point from the Farallon Islands. Is that, maybe not. Maybe we're going to keep chatting here. Oh, nope. There it is. This is a beautiful view back towards the Golden Gate as Wilson approaches. This camera is streaming to us from the Farallon's Pier classroom, courtesy of the greater, no, it is not. Correction, that is not streaming to us from there, but it is, we will be getting a camera shot from that fairly soon. So this is the Maersk launcher coming towards us. As I said, 12 people on board. Francesco is one of them, and one of 30 people on board. Great mix of nationalities there. Francesco didn't mention it, but there are some other vessels aboard the Maersk launcher. We have it's what we're calling the Mega Maid, so that will help in the process of picking up the plastic. The system will form a U shape, and then to extract the plastic, a specially designed net has been designed for the ocean cleanup. That's actually, the person helping us with that was a fisherman. He's a fisherman who normally fishes in Alaska, and now he's going to be fishing for plastic. So it's a very specially designed net to ensure that we don't catch any sea life when we are busy catching plastic. So the Mega Maid will help with that. And there's also another boat on board called the Autonaut. So that's going to be help keeping an eye on the marine life. Now, I think we're going to jump to Rachel next. And let's see how she's doing out in the bay. Rachel, can you see the Mega Maid?
So we are still going steady with Wilson. We're in the middle of the bay right now, following the Maersk launcher with our 600-meter ocean cleanup system floating wonderfully through the water. I mean, it's a little choppy here on the boat right now, but the system, looks like a breeze. It's so smooth. We have all the stabilizers. They seem to be doing really, really well. It's all seems, I mean, smooth sailing, no pun intended, but yeah, it's pretty incredible to see the system right now after all the years of work, and to see it being towed and about to make its way under the Golden Gate Bridge. We're surrounded by so many boats. We're passing Alcatraz, and you know, that's a pretty famous island for a lot of things, movies, prisons, all those stuff. But it's so cool to pass all these amazing landmarks here in San Francisco with the beautiful skyline and see our cleanup system making its way into the Pacific. And for those of you who aren't familiar, we actually plan to take this out all the way to the Great Pacific Garbage Patch. And the idea is that once we have a full fleet of systems, we will clean up 50% of the plastic in 5 years' time. So this is actually our beta system. We want to learn from this. It's it's just going to help us learn and grow. We believe in an iterative design process. So System 1, or Wilson as we like to call it, is really going to help us learn so much about how it performs so we can make better systems to hopefully clean up more plastic. It's, yeah, and I actually even think I see some of my colleagues up there on the Maersk launcher who helped build the system and are going to spend the next 6 to 8 weeks out there with it. So it's also an exciting day, not for the cleanup system, but for all of them aboard as well.
Thank you very much, Rachel. It's great to see the team out there on the bay. Rachel mentioned that this is going to be going out into the middle of the Pacific Garbage Patch. It's actually going to be located halfway between Hawaii and the continental United States, somewhere right in the middle. And we will actually be bringing plastic back as soon as is possible. The system will start working from the get-go. And one of the things you may have noticed in some of the shots that there's a Dutch flag on the side of the system. That is because this system is actually flagged in the Netherlands. So that is thank you to the Dutch government for helping us sort that out. It is one of the it is the only unmanned flagged vessel in the world. So that is a fun little fact. Now, you maybe, if you are out in the bay, we've seen some sailboats, we've seen motorboats. It's fantastic to see all those people out on the water. Please send us your pictures. Make sure to tweet your feelings and your response. This is a historic moment. We are very excited here at the Ocean Cleanup, and we very much hope that you are as well. The idea is for this system to stay out at sea for about a year, but of course the big test will be the coming months and the storms and everything that the Pacific throws at the system. I think next we're going to be showing some more images of the system. Oh, now, as I said, set location. Let me run through again how the system is designed to work. So you see it now as one big 2,000-foot, 600-meter long section of pipe. Once it's out at sea, it is actually going to form a U-shape, and the plastic will gather in that. The plastic goes in there because the system actually behaves like a piece of plastic. There's no engine on board or anything of that sort, though there are solar panels which are going to keep the instrumentation alive for many months at sea. Once the plastic is collected, then it will be gathered by a boat and brought back to shore for recycling. The idea is to have 50% of the Great Pacific Garbage Patch cleaned up in 5 years' time from the 2018 baseline. We're starting with the Great Pacific Garbage Patch because it is the largest garbage patch in the world. It is one of 5. I'm going to run through some of the numbers again just because it's absolutely crazy when you start thinking about it. We have 1.8 trillion pieces of plastic in the Pacific Garbage Patch alone. That is 250 pieces of plastic for every human being on Earth. It totals 80,000 tons of plastic. That is the same weight as 500 747s. And we're actually going to show you a video, again, explaining how the technology works.
1.8 trillion pieces of plastic float at the surface of the Great Pacific Garbage Patch. Here, the Ocean Cleanup is deploying the world's first technological solution to this growing problem. The principle behind it is simple. Create a coastline where there are none. Concentrate the plastic and take it out. The system consists of a 600-meter-long floater and a 3-meter deep skirt attached below. The floater provides buoyancy to the system and prevents plastic from flowing over it, while the skirt prevents smaller particles from escaping underneath. As the impenetrable skirt creates a downward flow, marine life can safely pass beneath it. Here is how the system catches plastic. The system takes advantage of 3 natural oceanic forces: winds, waves, and currents. Both the plastic and system are being carried by the current. However, wind and waves propel the system only, as the floater partly sticks above the surface, while plastic is primarily just beneath it. The system thus moves faster than the plastic, allowing the plastic to be captured. The skirt extends deeper in the middle of the system than on the outer edges. As the current applies pressure on the skirt, the system naturally adopts a U shape, which enables it to concentrate plastic in its center, like a funnel. The drag generated by the skirt also acts as a stabilizing force, allowing the system to reorient itself when the wind changes direction. And because the system, like the plastic, is free-floating, it automatically drifts to the areas with the highest plastic concentration. Fitted with solar-powered lights, anti-collision systems, cameras, sensors, and satellite antennas, the system actively communicates its position at all times and continuously gathers performance data. Periodically, a support vessel comes by to take out the concentrated plastic, like a garbage truck of the ocean. The plastic is then transported to land, recycled, and made into durable products. This is the first of a fleet of 60 systems. Once deployed, the fleet is expected to clean up 50% of the Great Pacific Garbage Patch every 5 years.
So a very simple concept, but obviously requiring a great deal of expertise and knowledge to make this all come together. Now, you may be wondering a little bit about how some of the design was informed. Well, that actually goes back to this mega expedition that Boyan started. In some ways, the system involves a great deal of work and a great deal of expertise has gone into that system, but to even get there, there was a great, Boyan was very intent on understanding the idea thoroughly before the system, to inform how the design of the system was going to work. So that was where the mega expedition came in. That is where a lot of the numbers during today's show come from, the 1.8 trillion that I mentioned earlier. They also found out that the Great Pacific Garbage Patch is enormous, which is where they were mentioning the 3 times the size of France. We just saw in that little documentary, twice the size of Texas. And one of the things that's important to remember about the Great Pacific Garbage Patch is that it is not a big garbage dump with an enormous amount of plastic piled up in one corner that is easy to pick up. This is plastic that is spread out in various different forms. It involves ghost nets, it involves pieces of fisheries equipment, it involves plastic bottles, a lot of stuff, and many are small pieces. One of the important things to also remember is that at this point, 98% of the pieces of plastic that are in the Pacific Garbage Patch are larger than 5 millimeters. That means that they are not yet microplastics. The longer plastic stays out there, the more microplastics we get. So therefore, it is a problem that needs to be tackled sooner rather than later. So this is the Maersk launcher. I was aboard the Maersk launcher earlier this week, and it is, as I said earlier, there are 30 people aboard there, 12 of whom are with the ocean cleanup. We're coming up on the Golden Gate Bridge. Beautiful view there. And we can see, gosh, it's just fantastic to see those images of the Golden Gate. So if you are wondering where the ocean cleanup fits in the grand scheme of history, the Queen Mary II has gone under the Golden Gate. The Led Zeppelin has gone over the Golden Gate. We have just some very historic expeditions and vessels that have gone over and under. I actually think the Space Shuttle Endeavour also flew over in the not too distant past. So some beautiful images here. The system is going to be coming up on the Golden Gate relatively soon. We're moving a little bit ahead of schedule here, which is not a bad thing. I think it's a sign that the system is keen to get out and start doing work. Now this system is shorter than future systems will be. It is 600 meters long, 2,000 feet. And we expect future systems to be between 1 and 2 kilometers long. There are going to be 60 of these systems. That is the number required for the target that the ocean cleanup has, of cleaning up 50% of the Great Pacific Garbage Patch within the next 5 years. So this is just the beginning. It's actually quite important to remember. We're very excited about what's going on today, but it is just the beginning. It's exciting for all of the team here to be coming up on the Golden Gate Bridge, but obviously for Boyan, this just must be an incredible moment. He had this idea when he was 16. He was out in Greece on a family holiday. He saw a lot of plastic in the water. He says that he saw more plastic in the water than he saw fish. And that's what inspired him to start the ocean cleanup. There he is. He has been doing so many interviews over the past couple days, but I don't think looks like he's flagging, and he must be very excited to be on the water and see the system finally going out. As we were saying earlier, there are a lot of challenges that remain, and of course the biggest challenge is knowing whether this is going to work precisely as it's designed to do. So we have been moving along at a speed of between 2 and 4 knots. So that is slower than you'd be going out if you were a large ship. The Maersk will be heading out into the Pacific. It will take 3 weeks for it to reach the Pacific Garbage Patch. It will be stopping about a week out and doing some tests while they're a little bit closer to shore, making sure everything is working according to plan. You can see Alcatraz in those images, which is a great San Francisco institution at this point. I'm sure many of you guys have been out there and visited. It's great to see the system passing by so many special San Francisco landmarks. I think the people of San Francisco have really taken this project to heart. Feels like every time I've bumped into somebody, they've said something nice and about this project and how excited they are. Beautiful sailboats out there as well, enjoying the wind. We are going to jump back to Rachel and see how she's doing. Rachel, what's it looking like on your end?
Hey, so we are still out in the bay right now with System 1. It's an amazing site. We are getting closer to the Golden Gate Bridge. Well, the system is right now. We're going along the system in the opposite direction, but we are still amazed at how well it's doing. We have Alcatraz over here right behind us, and it's actually, I heard it was a bird watcher's bonanza, but it's actually looking like that's what our system is with all the birds on top of it. It's, again, it's just a beautiful day, and I really can't reiterate enough at how amazing this is. I've worked with the ocean cleanup for 2 years. I've seen scale models. I've seen the drawings online. You know, you see the prototypes, but whenever you actually see the system in person, it's absolutely incredible. And right now, we are actually coming up to the Harbor Emperor. This is the media boat with all of the people. Say hi, everyone, you're live! Right now, these are a lot of the people there are a lot of people who work with the ocean cleanup, the media, who, here to send Wilson off. And we're doing a quick handoff. Always something at the ocean cleanup, right? You know, we stay on our toes. And hello, gentlemen. And, yeah, so we did it all for Wilson. And actually, Boyan is right up there on the boat. It's pretty cool to be here, knowing how amazing this must feel for Boyan right now. I can imagine right now he has a mix of excitement and nervousness. This is his baby, and you see that. I mean, at the office, he works with the communications team. He works with the engineers. He works with ops, finance, in a way that he wants to see this project succeed, and he cares so much. And you see that today with everyone in the team. We have an amazing group of people. I think we're at 85 people working for the ocean cleanup. And you see that energy and that enthusiasm for everyone. It's palpable. We're all working for the same goal, and we're all excited about it. So, you know, the late nights, the long work hours, they're all worth it, because today we're seeing that pay off. It's absolutely incredible. And we're even getting close to the Golden Gate Bridge now. That's kind of our iconic shot. We have a lot of computer renderings that have shown this system going under. So we'll catch up with you guys in just a little bit, but I'm actually going to send it back to you, Kari, and I'll talk to y'all soon.
I was just had my eyes on Rachel. It looks like she's having a nice time out there on the bay. It looks like it's getting a little bit rougher, but the system should be able to handle that, because it's going to be going out into the middle of the Pacific. It's got quite some very tough materials. As I said earlier, it's made of high-density polyethylene pipe. And the screen is actually coming all the way from Dubai. It's a system that is made from parts from all over the world. That pipe comes from Austria. Now, I mentioned some figures earlier about the problem of plastic pollution. It actually costs $13 billion a year, according to the UN. And I think I've heard Boyan mention that the volume of 2 Empire State Buildings of plastic flows into the oceans around the world every week. So very important that this system gets out there and starts doing some work. There's the Maersk launcher. Between the Maersk launcher and the tow line and the system, there is over a 1 kilometer stretch. That boat is going at between 3 and 4 knots, and it looks like it is getting quite close to the Golden Gate Bridge at this point. We actually have camera footage from aboard the Maersk launcher. That camera you could just see that. And I mentioned the Mega Maid and the Autonaut. Those are both aboard the Maersk. So I went aboard the Maersk a couple days ago, and I met with the captain. He's from the Faroe Islands. They have a cook who is from Scotland, if I remember correctly. There's an Irish woman aboard, so lots of nationalities. There are 13 members of the ocean cleanup team. Those include marine biologists, engineers, and there's even a fisherman. He is normally fishing for salmon off the coast of Alaska, but over the next couple of months, he is going to be fishing for plastic. This system is going to go out into the middle of the Great Pacific Garbage Patch. It's going to take 3 weeks to get there, and then the idea is for it to stay there for about a year. Hopefully that is how long it will be out there. This will give lots of information, will be gathered while it is out there, and allow the next system to be designed and tweaked depending on what we learn from this one. As I mentioned earlier, the idea is for it to form a U shape. It's a little bit hard to visualize that given that it's stretched out in one big long line, but this pipe is quite flexible, so it will form a nice U shape, and then that's how it will start collecting plastic. The plastic we collect is going to be collected with a boat and then sent back to shore to be recycled. And I was talking earlier about how there are 1.8 trillion pieces of plastic out in the Great Pacific Garbage Patch. The significant 98%, the majority of this plastic is in larger pieces. And the longer it stays out there, the worse this gets. I've heard somebody here say that these larger plastic objects are almost like a mine for microplastics. Microplastics then are eaten by fish or turtles or seabirds. I'm sure you have seen all of these images. It can be quite unsettling. And the fish are things that we often eat. So it's not only important for wildlife in the ocean that this problem gets cleaned up, but it is also important for us and our health. I think we're going to get some shots from inside the Maersk boat. Quick reminder that this is just the beginning of this expedition, and we actually have a journalist and a cameraman who's on board, and he's going to be catching every minute of what goes on over the next few weeks. And there's Ric Martini. We saw him in the show earlier. He was our yard manager here, and now he is one of the chief operational men on board. That's the captain. As I said, he's from the Faroe Islands. I am a little bit excited about that because I've been to the Faroe Islands. And I'm also excited about this entire production because I grew up on a sailboat. Little fact about me. And so this issue is something that I've cared about ever since I was a little kid and seen my mother wandering along the beach picking up plastic. There we have this system. As I said, 2,000 feet, 600 meters of HDP pipe, and with a bunch of stabilizers on it. And they have quite a bit of electronics. As I was saying earlier, they have electronics that will give you a sense of how the system is being strained, whether there has actually it's been broken and there's water inside. Lots of sensors for things like that. But then, of course, there are navigational instruments. There are weather instruments. These are powered by solar panels on the pods, and there is a camera, and all of those sensors will help us figure out when it is time to go out and collect the plastic. The idea is to have 60 of these systems out at sea as soon as is humanly possible, so that is why your contributions continue to be of such importance to the ocean cleanup. I mentioned earlier that Boyan remains incredibly grateful to all of you who have contributed so far, either with the crowdfunding campaigns and also, of course, with your time and expertise. But continued support is essential to the success of this project. The Maris looks like it's closing in on the Golden Gate. It is going at 2 to 4 knots, as I mentioned earlier. It also looks like there are still quite a few people out enjoying this visual. It's this watching history in the making. I think San Franciscans like to see history in the making. They've seen a fair bit of it. The Queen Mary II has gone under the Golden Gate, the Led Zeppelin, the spaceship Endeavour, it flew over. I remember seeing some fantastic images of that. So some very special vessels that have gone both under and over the Golden Gate. And now here we have the world's first passive ocean cleanup system. Very excited about this. I might also mention another little bit of a personal history. I am a mother, and I feel like as a parent, my awareness of plastic has suddenly gone through the roof. So that's another reason I'm very excited about this. We are streaming to you using using technology from LiveU and from KeyCode, so thank you very much to them. Actually, one other thing I wanted to mention is that the emissions from this first year of expeditions are being offset with the help of South Pole, so thank you to them as well. So this isn't just about plastic, it is also about a broader environmental impact. It's one of the things that also makes me feel very positively about this project personally, sorry I'm going into a bit of personal details here, is the fact that I hope by tackling a problem of this magnitude, if we can actually tackle it and do something about it, that we will be able to tackle some of the other big environmental problems that we have out there. So there we have the Maersk launcher again. Boyan Slot himself, he is out on the Harbor Emperor, which has been being on loan from the Blue and Gold Line of San Francisco. I'm sure many of you San Franciscans have been on Blue and Gold Line ferries over the past years and over your time in San Francisco. The Maersk launcher will be taking the system out into the middle of the Pacific. It will take 3 weeks to reach the middle of the Pacific garbage patch. One thing you may be wondering is if we have a precise point for where the system is going to be deployed. We don't actually. That will very much depend on wind and weather and storms and a variety of different factors. So we will be giving you that information in a few weeks' time when we have a good idea of where it's going to be deployed. I'm going to run through again how the system works. It is going to be bent into a U shape, and then plastic will float, will be gathered in it. It sort of works like a giant funnel. These stabilizers that you see are to ensure that it doesn't roll over. The idea is for it to move passively. There's no engine on board, there's nothing like that. So it just moves passively through the water using wind and waves. So another way to reduce the environmental impact of the system. There are marine biologists aboard the Maersk. There's a whole team of marine biologists back in Rotterdam as well, and they are making sure that this system does not have a negative environmental impact. That is something that is exceptionally important to the team at the Ocean Cleanup. These shots are absolutely fantastic. I'm loving this. I spent some time in the Bay Area when I was in college, and it's just, I'm so glad that we had such stunning weather. You can actually see I think that's the Legion of Honor in the background. I hope you from San Francisco aren't upset if I get that wrong. But you see Crissy Field, Fisherman's Wharf. There's the Maersk. Oh, and you can see all of the Ocean Cleanup System 001 launch on the side of the boat. So thank you to Maersk for letting us play with their paintwork. We also are very happy with the color of the Maersk. It's right on brand, even though that was just coincidence. The Maersk and the tow line and the system together are over 1 kilometer long. I was chatting to the captain a little bit the other day, and he was telling me that this is unlike anything he has ever done before. I was asking him what the challenges are, and he was saying, well, the fact that the system is so light. He's normally pulling oil platforms, things of that nature. This system is 380 tons. A single winch on this launcher can pull 500 tons. So a very lightweight piece of equipment compared to what they are normally used to pulling. Also, it is exceptionally long. It is actually 1.5 times longer than your average container ship. So that makes for another challenge for the captain. One of the things he was concerned about was coming around the corner by Alcatraz. They had to make quite a sharp turn. Originally, they were planning to go around the north side of Alcatraz, but they actually decided to go to the south. And thank you very much to the Port of San Francisco for letting us do that, and for all of their help in making today happen. It required a lot of effort and teamwork. There you can see the pods on the system. They are going to be streaming back lots of information to Rotterdam, so the team there can make sure they know what is happening with the system. There are some lights as well. That is to make sure that ships see the system, and radar reflectors. If you are out at sea in the middle of the night, you will be able to see the system on your radar. So that is obviously very important to us, that our system that Wilson does not become a piece of debris in the middle of the ocean, contributing to the patch rather than cleaning it up. We are coming up on the Golden Gate now. There are the Marin headlands. I think we're going to be chatting to Boyan in the not too distant future. I will be checking in with him, I hope. As I said earlier, he's on the Harbor Emperor. I can only imagine what thoughts are going through his mind. From 16 years old, he has been dreaming of this. He is now 24 years old, 3 prototypes, and now here we are with this 2,000-foot long system. I'm sure it's getting quite emotional for him, actually. He says he doesn't cry, but if there's any sight that might make him tear up, it could be this. So Boyan is a bit of a workaholic. He is somebody that likes to work late at night. He is someone who likes to read challenging books. As I mentioned earlier, he is reading Global Catastrophic Risks. And he is obviously someone that cares a great deal about the environment, but he cares about practical solutions. We're going to be chatting with him in just a few minutes' time, and I'm very much looking forward to connecting you with him. He had to drop out of university to found the ocean cleanup. I shouldn't say he had to drop out. He did drop out because he really wanted to focus on this problem. He had $350 saved up, and that's what he started this project with. He did a TEDx talk. If you haven't seen it, it is fantastic. Oh, and it's time to chat with Bojan right now. Hopefully we can connect to him right away. I'm going to, yes, Bojan, can you hear me?
Okay. I can hear you.
Wow, how are you feeling in this moment?
So this is, I mean, I've seen this view. I've seen this view for, for years, just in artist impressions, just in computer simulations. So to see this now in reality is pretty amazing.
And what are you going to be watching for over the next months as the system heads out into the Great Pacific Garbage Patch?
So, of course, the next few months are going to be super tense. This is an exciting moment, but of course, the moment we're looking most forward to is to bring this first plastic back to shore. It's, because that means that it's proven technology, and that's what we hope to achieve with this first system. So next few months, I'll be really obsessively looking at the data that's coming in from the vessel, from the data streams, from the cleanup system, which will hopefully then allow us to catch the first plastic and bring it to land.
And I was just going to ask you that. What does the future look like for you and the ocean cleanup?
Well, of course, a lot depends on this first system and whether we indeed are able to prove that the technology works. But what I hope is that the ocean cleanup can become this example of how you should solve a problem, right? Instead of trying to complain or protest about something that you don't agree with, try and build something that you do agree with. And this is, of course, just the beginning. So if this first system goes well, then we hope to expand to a whole fleet of systems in the coming few years. And of course, hopefully in the future, I hope to be working on more problems besides plastic pollution as well.
We've been talking a lot about how the system was designed and put together. Did you ever have a moment where you just think, oh, wait, this just isn't going to work?
For sure, we had incredible hurdles to jump to get to this point. Whenever you hear the history of some technology, people are always reciting the history as if it was some kind of straight line, like first we did this, and then we did this, and then we came to this point. But it's easy to connect the dots in hindsight. When you start, you really don't know what's going to happen, and this is not just like building a slightly better cleanup system. This is like, it's not like developing a slightly better car or a better airplane. This is like developing the first car ever. So the number of hurdles we had to jump to get to this point has been immense. There were definitely points when we said, well, this doesn't look good. But fortunately, the team is super creative and super motivated. So every time we had been able to overcome adversity, and this got us to the point where we're right now, and hopefully also eventually to the point where we start cleaning the ocean.
And I was just going to ask, what is going to happen to the plastic once it comes to shore?
Yeah, so the idea is that we take the plastic back to land, and we work together with our recycling partners, and the idea is that we can process that plastic and turn it into very nice, desirable products that are durable, designed to not end up back into the oceans. And by selling those, we actually hope to help fund the cleanup and fund the operations of the cleanup system.
We've touched base with the team in Rotterdam. We've talked about all of your supporters, the volunteers, and obviously the people who were participated in the crowdfunding. Do you have any thoughts or any things that you want to share with them?
So just super proud of what the team has achieved, and it's just amazing to see this beautiful group of people come together. In terms of not just
passion, but also real expertise that we have been able to find some of the best people in the world to work with us has been great. So yeah, so it's an honor to work with them.
And you you are somebody who is very interested in engineering. You have been very hands-on in Rotterdam, here at the yard. What do you think has been the biggest engineering challenge?
Well, so over the past few years, it's mostly been the conceptual challenge. So, so really getting to a concept that we think could work, can be cost-effective, can efficiently collect plastic. That has been extremely challenging to have something that survives. That was, I think, the main challenge. But then over the past 12 months, we found, the same level of complexity that we found on the conceptual level, just repeated itself on the detailed level. Take, for example, the steel frames, those blue steel frames that keep the system stable. Just the tiny rubber that is between the floater pipe and these steel stabilizers, just engineering that has been incredibly challenging. Actually, we had a big failure with those rubbers just late July. So these are, like, on the detailed levels, some of the challenges that we had to face over the past few years.
And what are your biggest concerns? We were showing a video of you earlier talking about some of these points, the 3 points that you're most concerned about. Tell us about those.
Well, so I think the thing that I will be most closely looking at is how efficient can we collect the plastic. I think this is where the most uncertainty still lies. Of course, in terms of survivability, man has been building structures that have survived for decades on the oceans for a very long time. Catching plastic is completely new, and we've tried to simulate this, of course, with computer models, with scale models, but there's inherent uncertainty to that. Take, for example, the scale models. If you take plastic pieces that are this small and you try to make them 30 times smaller, well, then you get into all these scaling effects like surface tension, and when you think about computer simulations, well, that screen that's underneath it, that's behaving so erratically, so chaotically, that it's just almost impossible to simulate using computers. So that's something we can really only find out once we're in the patch. So the single metric I will be watching most closely in the coming weeks and months is, how efficient can we collect those, especially those smaller pieces of plastic.
2 more minutes. And you were 16 when you had this idea. What would you say to other 16-year-old inventors that are out there?
Well, I mean, if you have a good idea and it's to solve a real problem, I would definitely recommend people to just try. When I started, I really didn't have a bloody clue on how to be an entrepreneur, how to be an inventor. But as long as you're willing to listen to feedback and learn fast, you can actually get things done.
Are you surprised at how much the design has changed? This looks unlike anything when you first sat down. I've seen some of the first sketches, and this doesn't look anything like it.
Right. So I think every single detail has changed on the design over the past 5 years. But it's not so strange, the fact that it's a completely new device. Of course, you're going to learn a lot through progressive insight. But when you look at, if you compare what we've built right now compared to the initial idea, most of it has changed, but the basic principle of working with nature so working with nature, to have a passive system, to build an artificial coastline, that hasn't changed. So it's really how we do that which has changed 100%.
One final question for you, Boyan, and then I know you have other people to speak to, and we should also give you a moment to just enjoy the moment. The San Francisco Bay, we are towing out under the Golden Gate. What do you want to say to the people of San Francisco?
Sorry, could you please repeat that question?
Are you happy to be coming out of San Francisco Bay, and has it been a good experience building the system here in San Francisco?
Oh, for sure. I mean, we've had so much support here in the Bay Area, but really all around the world. And yeah, we have been proud to call this our home base for the building of system number 1 over the past 6 months. And although it is very exciting to see it going through the Golden Gate Bridge, I will definitely miss visiting this place on a regular basis.
Thank you very much, Boyan. We will let you get back to enjoying this moment, and enjoy the rest of the day.
All right, thank you.
We are getting close to the climax of this morning. The Maersk launcher and the system are nearing the Golden Gate Bridge. As I said, the Maersk launcher is going between 2 and 4 knots, but it actually starts speeding up once it gets closer to the Golden Gate because of the currents there. It also looks like it's getting a little bit choppier out in the bay, but it looks like the system is riding it just fine. Quite a challenging tow for this vessel. As I mentioned earlier, this vessel is used to towing things like oil rigs, so the captain was looking forward to towing a system like this that is going to help clean up a problem that human beings are making. Beautiful shot of the Marin headlands there and the Golden Gate, and it's so much fun to see all these vessels that are out accompanying the system out into the ocean. Thank you very much to the Port of San Francisco for all of their help, to all of the people that have helped us along the way and helped supply parts of this system. From this point, the system is going to go out into the Pacific Garbage Patch. That journey will take 3 weeks. It is going to go out for about a week, and then it will stop, do some testing, and then continue its journey to the Great Pacific Garbage Patch. We do not have a precise location for its deployment. That will depend on the weather, on various different factors, but it will be pretty much right in the middle of the Pacific Garbage Patch between Hawaii and the west coast of the United States. The goal is to have half of the Pacific Garbage Patch cleaned up over the next 5 years. That's going to take many more systems than system number 1. Wilson is going to have some friends. We're going to need about 60 systems. Those future systems will be much longer than the one that you are seeing today. Wow, that is just a beautiful image of the Golden Gate. And I'm sure that if you are on the Maersk launcher, or if you are a Boyan, you are having quite an emotional moment seeing all of your dreams come under this iconic bridge. I mentioned earlier some of the other things that have gone over this bridge: the Space Shuttle Endeavour, the Queen Mary 2, the Led Zeppelin, the Pan Am Clippers, the China Clipper. It also flew over this bridge. So some very iconic expeditions, journeys, vessels that have gone this route. The Maersk launcher includes 12 members of the ocean cleanup team, so they will be on board, keeping an eye on how the system works. They will be staying out there into October. So the good news is that the cook on board is very jovial and a good cook, and so they won't be losing any weight. That is a video camera from inside the Maersk launcher. There is also a journalist on board, and he will be continuing to take footage. So the story does not end today. This is a continuing story. Boyan was mentioning how important continued support is, and how sort of nervous he is about what the next months hold, and that's because this has never been done before. We have had prototypes that have seen how a system like this will stand the wear and tear, but the actual collection of plastic has not been done before, and so we just have to hope that it works as planned. But the good news is that you have a team that is used to challenges, And they are used to things breaking, and they're used to redesigning them so that they will work. So that is, as I said earlier, design, test, break, repeat is a bit of a mantra here at the Ocean Cleanup. Make sure to look at theoceancleanup.com. There will be continued information over the coming months, and you can show your support, of course, and by donating to the mission at theoceancleanup.com. Continue to follow our hashtag, hashtag #TheOceanCleanup, at @TheOceanCleanup. We've been very grateful to your input on social media today. Continue to send us your pictures and share your thoughts. We love hearing from you. These are just beautiful shots. It's going to be fun in the coming weeks. We have a lot of cameras around the bay that are that we're streaming live using LiveU technology. But we're actually in the coming months going to be seeing photos from the system itself, from Wilson, from the camera that is located in the middle of the system. Just a reminder of the problem that we are tackling. This is a problem that costs the world $13 billion. There are 1.8 trillion pieces of plastic in the Pacific garbage patch, 250 pieces for every human being on Earth. And this is a problem that is only getting worse. At this point, most of these pieces are larger than 5 millimeters, which means they are not yet microplastics. The longer they stay out there, the more wear and tear, the more sun they are, the more that they break down and become microplastics and get into our into our fish, into our birds, and eventually into us. This is going to be a beautiful image in a few minutes' time, coming here up under the Golden Gate Bridge. And we're going to be getting ready to say adieu to System 1, to Wilson, hoping that he does a good job once he actually gets out into the Pacific garbage patch. Part of this system has already been out at sea, a 120-meter section that was used for the tow test, but the rest of the system has not. There are lots of sensors all over the system to help engineers and know what is happening to the system when it is out at sea, so those will be monitored closely to see how it manages. It's quite a simple concept. It is one big long pipe made of high-density polyethylene that is about 1.2 meters wide. I think that translates to 48 inches, so quite a narrow pipe. Then from that hangs a 3-meter screen, a 3-meter screen. It tapers actually, so 3 meter at its deepest point. That is made of a very sort of soft material. I expected it to be a bit like a sail, but it's actually quite soft. There is Boyan Slat himself, ladies and gentlemen, the man of the hour, the man behind the idea, seeing the culmination of his work over the past 7 years, seeing his idea from 16 years old head out into the Pacific. I think he actually sketched his first concept for how this could work on a napkin while he was on holiday. And there we are going under the Golden Gate. Almost time to say goodbye to Wilson, but we'll keep with him for a little bit longer. As I was saying before, this is a high-density polyethylene pipe. It is, once it gets out to ocean, it is going to be moved into a curved shape, into a U shape, so it can collect plastic. It is completely passive. There are no motors or engines on board. It just uses the wind and waves to drive it along. As long as the system moves faster than the plastic, it will collect plastic. How it is designed was informed very much by the mega expedition that Boyan and the team did several years ago. That expedition told us a lot about the Great Pacific Garbage Patch. It's been the source of much of the information I've mentioned to you today. But they went across the Pacific with 30 vessels and across it with 2 airplanes and learned a great deal about the Pacific Garbage Patch. I think we are going to wrap things up and leave you with a few shots of Wilson as it goes out under the Golden Gate. A whole new story will begin with new faces and new adventures. Please follow along over the next months as the ocean cleanup progresses to the middle of the Great Pacific Garbage Patch. As I said, keep an eye on the oceancleanup.com. It's a big relief to everyone here that this has actually been a successful launch, that the weather has cooperated, that everything has gone to plan, so we hope that that continues. Boyan once said that no high school project in the world has run quite so out of hand. Let's hope that that continues to be the case. I'm going to say a quick goodbye to Rachel. I think we're actually, I'm not sure if we're actually going to jump to her camera, but we're just going to say goodbye.
There you have it. We have just passed the Golden Gate Bridge, the iconic moment. It's absolutely incredible. I have the coolest job in the world, and I feel so incredibly lucky to be here right now today. Seeing System 1 as it goes out to the Pacific, I remember my mom telling me about her seeing the space shuttle take off, and I feel like today I'm witnessing the same type of history, and all of us are. We're all a part of this, and it's absolutely incredible knowing that right now this system is going to go and start taking out plastic that we've been putting in there for years. In the same way that the space shuttle explores space, we're exploring the ocean to make it better for the world. So I hope you feel just as lucky as I do. Thank you all for being here today, and I'm going to send it back to Carrie and just celebrate this amazing day. Thank you.
It looks like we're actually getting another water salute, so that's great. A 2 in 1 day. That's fantastic. Well, thank you very much for watching. It's been a real pleasure hosting this, and it's so exciting that everything has gone to plan so far. I'm going to be very excited myself to see what happens over the coming weeks and months. Please stay tuned. Sign up for to stay in touch at theoceancleanup.com, and definitely continue your support. So, thank you very much from the team here. Adios.